that. Here we go. And Teacher Leanne, welcome. We're so happy to have you with us here today.
All right. Thank you so much, Tanya. I appreciate being able to have the opportunity to present to all these wonderful students and teachers out there. So I loved seeing things coming in on the chat. So I am more than happy to take questions throughout the program. If we end up kind of getting close to running out of time with too many questions, I'll kind of, just kind of see how we're doing if we're able to cover those. But as we go through our activity today, feel free to ask questions about the activity. And I also want to encourage you to participate in the chat. There might be some times where I ask you some questions, and I would love to hear your answers or your thoughts in the chat. So you're going to be able to watch an experiment today and learn a little bit about something that it all has to do with weather and air and kind of how all these different things connect in order to give us different types of weather. So I would love for you to kind of put some of your thoughts and your answers into the chat as well. So we'll go ahead and get started here. So my name is Leanne, and I work for a company called the University Corporation for Atmospheric Research. And that is a company that manages a place called the National Center for Atmospheric Research, the NSF NCAR. And there are lots of different letters floating around in those different acronyms. But this is the Mesa Lab facility pictured behind me here. So this is one of the NCAR facilities where scientists will study and learn all sorts of new things about the atmosphere and weather systems, things like predicting weather and even looking at long-term weather patterns, what we call climate, okay? We look at things, everything from severe storms to how do we collect more data about different things like severe weather or even day-to-day weather to make things even better for everybody who needs accurate weather forecasting and studying all sorts of different things about the Earth. So what we're going to focus on today is mostly talking about air and temperature and kind of how that all comes together and gives us what we call different pieces to the weather puzzle. Okay, so weather includes lots of different things that come together to give us different weather systems. And a couple of those things we're talking about being how air changes with temperature. We'll also talk a little bit about clouds and kind of how all of that comes together. So you'll be listening to some instruction, but then also watching an experiment that I have set up right next to me here. And this is going to be an opportunity for you to be just like scientists, right? You can watch these things and you can observe, right? Looking with our eyes and then thinking about what's going on and then coming up with different ideas and thoughts and questions. That's kind of what all this, learning science is all about, is doing all these different experiments and kind of observations, and then kind of coming up with thoughts about what might happen next. All right, so we'll go ahead and get started here. So let's show a fun picture of some clouds behind me here. Like I said, these clouds are kind of part of different weather systems that happen because of different changes within our atmosphere, okay? Like I said before, one of the big things we're talking about today is air. So let's kind of take a look at this fun image here. If we were to be able to look at air, little pieces of air molecules up really close, which we can't do that with our own eyes, but if we were to kind of pretend like what they looked like if they were moving around us, they might kind of look like this. Now, they might not be as bright and colorful. These are kind of fun cartoon air molecules, right? But what I want you to get an idea of is just kind of how they're moving around, right? If you have learned anything about solids, liquids, gases, maybe you've learned some about those terms. The air is a gas that kind of moves all around us, but we can't see it, right? We can look around in our homes and our classrooms and the spaces that we're in. We don't see that air moving around us, do we? But we can, we know that it's moving around us, and sometimes we can feel the air. We know it's there because we can take a deep breath in and blow it out. Sometimes and you can even try this too. If you kind of move your hands back and forth like this, can you feel the air moving in between your fingers and around your hands, right? We know it's there around us, okay? But what I want us to look at is how this air changes based on temperature changes. Okay, so how is this air going to move differently if it warms up or if it cools down? Okay, because what we're going to see is because of those changes, certain things could happen to those different air molecules. And when I say pieces of air, that's kind of what I'm talking about, are all these tiny little particles of air kind of moving around us. Okay, here's some more clouds up in the sky. All right, so I'm going to show you what I have over here on my table for our experiment. Okay. Now, as you see these things, you might be thinking to yourself, well, gosh, those supplies seem kind of simple. Maybe this is something I could set up at home. And you're absolutely right. But the thing I want you to remember about this setup is that part of it does involve very hot water. So if you choose to set this up at home or in your classroom, make sure that you are getting adult help with some of those harder parts with the hot water and some of the setup. And you'll see kind of what I'm talking about over here. But it is something you can do at home. Okay. All right. So, oh, and my camera's turned off here. Let me make sure that's on. There we go. All right. So we've got 2 buckets of water here, one labeled hot and cold. Now, what I'm going to do before I get started, now earlier I had a bunch of ice in this cold water here just to really lower that temperature. I'm going to add just a couple more ice cubes in there just to make sure it's nice and cold. And then what I'm going to do with my hot water is I'm going to kind of refresh with even more hot water because we want a really big change. We want a difference in temperature for this experiment. So we've got 2 different temperatures of water here. And then here in the middle, I have kind of a soapy water little bucket here, a little cup. It's just soap and water solution. Okay. And then what I'm going to use is also a little bottle that kind of looks like this. Okay. Actually, let me go back to my other camera here because I have a question for you, and you can put your answer in the chat. And I want you to take a look at my bottle here. And so I want you to think in your head, do you think this bottle is empty or is it full? Is it empty or is it full? And you can think about it, or you could put your answer in the chat. What do you think? Is it empty or is it full? I'll kind of move it around, kind of put it closer there so you can kind of see, is it empty or is it full? What do you think? Kind of, we've got a few different answers here. We've got some empties, we've got some fulls. Okay, we've got full of air. Okay, yeah, so it's full of air right now, right? Now, when I kind of go like this, you might think, oh, that's empty because it doesn't have anything in it that's kind of like pouring out of it, right? But it is full of air. So inside this bottle has air, right? Just like that air that's moving around us, okay? And so what we're going to do is using our experiment table, we're going to be able to trap some air inside this bottle. And that's what that kind of soapy water solution is for, is if you've ever blown bubbles before, right? So you kind of dip that wand in the soapy solution and then you can blow the bubble. And that's a really good way to trap some air, right? So we're going to do the same thing. We're just going to get kind of a little soapy water film right over the opening of the bottle there. And that's going to trap that air inside. So what we're going to do for the first part is we are going to use the hot water. Okay. Now over here, back on my experiment table. Oh, camera keeps turning off. I'm not sure why it's doing that. So back over here, we've got the hot water. And just to give you an idea of the difference of temperature, I want to use this device here. This is called an infrared thermometer. So what I'm going to do is I'm going to take the temperature of these two, the hot and the cold water, just to kind of show you what the change of temperature is. Okay, so I see 107 degrees Fahrenheit for the hot water side. Okay, and let's check the cold water. And the cold water is 49.1 degrees Fahrenheit. Okay, so that's a big change in temperature. So that's going to allow us to see that change of air temperature a lot better. So what we're going to do is we're going to first trap the air inside of this using kind of that soapy water solution there, get a little film over the top. And then what I'm going to do for the first step is once we get that soapy film on there, I'm going to sit the bottom of this bottle into the hot water. I'm going to sit it into the hot water. So then what I want you to do is now think in your head, and you can type your answers in the chat. What do you think is going to happen when I set the bottle into the hot water? Okay, so we've already established that we've got air inside the bottle, and we're going to trap it inside there with a bubble on the top, kind of a soapy film bubble, uh, over the top there. We set it into the hot water. What do you think is going to happen? Okay, the air will expand. It's going to burn. The bubble will come out. It'll blow a bubble. Lots of different great answers here. What do we think's going to happen, right? This is all part of being a scientist. We make observations, but even before we do anything, we kind of think about what might happen. Okay, a bubble will come out. It'll make a big bubble. Okay, well, let's kind of find out what happens now. So I am going to grab one more thing here. And we're going to try this first step out. Okay, now earlier I mentioned that you can do this at home. You can do this setup. Now, you don't have to have a bottle that looks just like this. Okay, you could actually use all sorts of different types of bottles. You could even try different sizes of openings. Like here's another one here with kind of a bigger opening. You could kind of see how that works as well. So what I'm going to do is we'll get that soap on there. And then I'm going to hopefully be able to show you what happens. Now, sometimes when we're working with soapy water solution and creates those bubbles, bubbles like to pop, right? So sometimes we kind of have to do things a couple times here, and that's okay. All right. So we've got that soapy water kind of over the top. You can kind of see the reflection of the lights there. So let's set it in the hot water and let's see what happens. Look at that. Look at what is happening. A lot of people were saying that that bubble was going to come out or it was going to blow a big bubble. Look at that. That is exactly what happened. So my question to you now is, okay, we started to see that bubble come out. So my question to you is, why was that why do you think that was happening? Okay? And remember, all of the air inside of that bottle, we put it into the warm water. So we were warming up the air, weren't we? But why was that then causing the bubble to come out? What do you think? What do you think might be the cause for that to happen? Why was that bubble coming out or expanding? We could even use the big fancy word of expanding. Okay, yeah, it was rising out of there, right? Expanding out. Okay, the hot water was blowing the bubble. Hot air rises. What do we think? So we made an observation, and now we can think about what was happening. Ooh, the molecules were moving faster. Hot air rises. Yeah. What do we think? Any more thoughts? Any more answers? Okay, it was rising. Okay. Touch the bottom of the bottle, it would break. It was going up. Oh, okay. All right. So it was kind of getting away from the bottom of the bottle. Okay. So let's kind of think about some of those answers that we're thinking about. So a lot of people were saying that it was rising. You're right, that bubble was expanding because hot air rises. And so that if the air was rising up, it's going to push that bubble out. Another one of our answers said the molecules were moving faster. So remember that kind of colorful cartoon picture of air behind me here? All those pieces of air molecules were indeed moving faster because they were warming up. Okay. And when things start to move faster and those pieces of air kind of moving and they're wanting to take up more space, right? So they're moving up, hot air rises, but they're moving faster and they're taking up more space. So all of those things would make sense as to why that bubble was expanding or coming out of the bottle. Great job. So for the second part now, I'll do the exact same thing. I'm going to put it in the hot water. We know that bubble's going to expand out because we just saw it, right? But then what I'm going to do, and hopefully my bubble doesn't pop while I'm doing this, but like I said, we'll try it again if we have to. When we have our bubble up there, what we're then going to do is switch it over to the cold water. Okay, so we'll do the hot water. We're going to see that bubble expand, but then I'm going to switch it over to the cold water. What do you think's going to happen when I switch that bottle over to the cold water? Go ahead and put your guesses into the chat. What do you think will happen then? Do your guess, your hypothesis. Okay, the bubble will contract. I love that word. Okay, it will sink inside, it will go down. The bubble will go inside the bottle, it'll pop, it'll go back in. No bubble. Yeah, lots of great thoughts here. It might pop. Okay, the bubble will pop or get sucked in. Okay, so we've got some great thoughts here. So what we're going to do is switch over and see what actually happens. Okay, I'm going to grab myself a new bottle here because the other one's kind of soapy. All right, so let's see. Yep, the bubble will go in the bottle. Good. All right, so let's see what happens now. Trying this again. Okay, so we've got our soapy water here. Let's get that bubble going. All right, let's put it in the hot water. Now we know what's already going to happen because we just did this part. So there's our bubble coming out. It's expanding, and we're going to switch it over to the cold water and look at it go down. All right, we had some correct guesses there that the bubble would go down or it would kind of be pulled down into the bottle. So what you couldn't see super well from my experiment camera was that that bubble, before it even popped, kind of went down into the bottle and it was kind of going right down there into the neck of the bottle. And it was being drawn down into the bottle. So here's my question again, and I asked this for the first one, right? When we did the hot water, why did that bubble expand? So now my question is, why did the bubble contract? Why did the bubble contract? Why do you think the bubble went back inside the bottle now? So if you remember, think about what we talked about, what air does when it warms up. It rises and it moves faster and it takes up more space. Okay, so the molecules slow down It doesn't want to take up as much space when they slow down. Yeah. The cool water made it go down. It loves cold, but not hot. Okay, what do we think? Why did that bubble contract? And I love those words, expand and contract. Okay, any other thoughts? Why did it go back in? Couple more seconds for any other answers. I love the thoughts that we're kind of coming up with. We observe with our experiment table, and then we really think about what's happening. So as that air was cooling down inside, okay, those molecules then started to slow down, right? So if hot air rises, cold air actually sinks. And the warm air makes those molecules move even faster. And so the cold air is going to make it's going to actually move slower. So here's the tricky part about um, really what was happening is that bubble wasn't actually getting sucked in. It was actually being pushed in because now all of the air outside of the bottle is warmer. Okay. And it's going to take up some of that space because remember that air inside there now, when it's cooling down, it's kind of sinking down and it's not taking up as much space. But now that all the air around it is actually warmer than the air inside. So it's actually going to push the bubble down into the bottle. It's not going to suck it down. It's actually going to get pushed down in there. So that is the big changes that happen to air when the temperature changes. So let's talk about, well, what does that have to do with weather and clouds and all these different types of things that we talked about before? Well, a really good way to heat up the air is with the sun. Okay. The sun heats up the air, it heats up the ground, it heats up the water. Okay. And then as that air is heating up, we already know what direction it's going to go. We know that that warm air is going to start to rise. Okay. And as it rises up, there's all of these little particles of moisture in the air. We call that humidity or the level of moisture in the air. Okay. And it's going to start to condense around things like dust particles, and eventually it's going to form clouds. Once they kind of start to cool down, okay, so the moisture in the air, once it's rising up with that, it's getting pushed up by that warm air, and then as it starts to cool down, it kind of condenses and becomes clouds. Sometimes we get really big clouds, okay? But then what's going to happen if those clouds get too heavy with all that moisture and the warm air can't push them up anymore? That's when we're going to end up getting rain. Okay. Or if it's cold enough, snow, right? We could get that precipitation. That's a big word. So the moisture kind of coming down from the clouds is that precipitation. Okay, so just to kind of summarize and wrap things up here, let's think about how air changes based on temperature. So as air moves around us, right? We can't see it, but it's around us. We can breathe it in and out, right? We know it's there, but as it warms up, what's going to happen is it's going to go up, right? Hot air rises, but it's going to start moving faster and it's going to try to take up more space. Okay. But then as it cools down, it's going to start to move slower and it's going to sink down and it's not going to take up as much space, right? And so as that warm air goes up, okay, and it kind of pushes that moisture up, and as that moisture cools down and ends up forming clouds, okay, we're going to end up with some weather if those clouds can't hold in that moisture anymore. So that's where we end up getting different types of weather. So all of these different things, like I said, way back at the beginning of our lesson, are kind of different pieces to the weather puzzle. There's lots of things that can influence weather. And those are just a couple of the things, okay? And maybe you have a favorite kind of weather, right? Maybe you really like the hot, sunny weather. Maybe you like the rain or the snow or the cold or maybe the wind, right? there's all different types of weather, and all of these different things can influence the weather systems. Okay. All right. So, um, we're just out about time here. Let's see, one question here. Um,
Yeah, we have a great question in the chat here that
oh
came to us
yeah.
as
Oh
panelists. So,
yeah, that's a great question.
yeah,
The air that comes out of our mouths is kind of steam. So what's happening is as that air comes out, we're going to see it as kind of when it kind of looks like steam. It's when the air outside is really, really cold. So what's going to happen is we breathe out, there's some of that humidity in our breath when we think about the moisture in the air. And if we breathe that out and it's really, really cold outside, it's immediately going to condense that air, those air molecules, and kind of make it appear as if it were like steam, right? But if we just kind of breathe out in in our classrooms, in our homes, in our rooms, we don't really quite see it the way that it kind of looks like steam if we were outside, if it were really, really cold. And it feels kind of warm because it's coming from within our bodies, which are a much higher temperature than the air around us usually, right? Okay, so great question though. Wonderful
isn't
question.
that a wonderful question?
Yes, I
We've got
love
some really great thinkers on
yeah.
the on
Yes,
our
it's
in our group today.
that's great. Come up with those different
Yeah.
questions. Well, students, thank you so much for learning with me today and kind of watching my experiment. And again, it's something you could certainly do at home yourself. Just be careful with those extreme water temperatures, right? Maybe get some
Yeah,
help with the different supplies, but you can get some help at home and try some of those things out yourself and just see what happens. So thank you so much,
absolutely.
Tanya, and I'll turn it back over to you.
Yeah, that sounds great. So thank you all for joining us today. I am putting in the chat the link because we do appreciate learning with you here today, but it's also really great that you can schedule a time with Teacher Leanne and the UCAR Center for Science Education. And you will learn more about weather if you do that or other topics related to it. You can visit their member page on CILC website, and I've included the link in the chat. And then I also want to give you the heads up that we are back again tomorrow. And so we have a really interesting presentation again tomorrow. We are going to be back with the National Museum of Asian Arts Conservation Labs, where conservators are going to repair and preserve artworks. Join us for a special program about the history and conservation of the iconic Peacock Room. So reserve your spot today, and the link is in there. And so, again, thank you. We encourage everyone to keep learning and do that exploration, as you said, Leanne. And we hope you'll join us again at CILC soon. Thank you all.
Thank you, everybody.